everybody. Today we're going to talk about adding and subtracting mixed numbers. So in the last video we talked about adding and subtracting fractions, and today we're just going to extend that to mixed numbers. And this goes with the learning goal: I can add, subtract, multiply, and divide mixed numbers. So again, obviously we're just taking the first half of that learning goal for today. So we're going to start off thinking about an example where we have some candy bars. So let's pretend you and your friend have some candy bars. You got 4 candy bars, plus you have another candy bar that you've eaten some of. And you can see that this candy bar right here, as well as all the other ones, have been divided up into 6 pieces, and this one has 2 of the pieces missing. So there are 4/6 left over here. So we would represent the amount of candy bars here on the left-hand side of the screen as 4 whole and 4/6 of the candy bar that's been eaten part of. And then if your friend comes along and brings 3 whole candy bars plus this candy bar where 1 piece has been eaten, so they have 5/6 left over, and we want to put all of our candy bars together and see how much candy you have in all. So we have 4 and 4/6 plus 3 and 5/6, and we're combining all of those together. Now you can kind of see, you can count up the whole candy bars, 7 whole candy bars, which is what I would get if I added these 2 whole numbers together. So if I added the 4 and the 3, I would end up with 7 whole candy bars. Plus, I could move 2 of these 6 over like this, and you can see that I would make another whole candy bar, plus then I would have a half left over. So if I do this by rearranging, I can see that I would have 7 plus the 1 more whole that I made by moving the pieces, plus 1/2 of a candy bar. And so that would give me 8 and 1/2 candy bars if I put them all together. So this is the idea of what we're going to be doing. We're going to be adding or subtracting mixed numbers. Most of the time when you add or subtract mixed numbers, you don't want to leave fractions as mixed numbers. You want to change them to improper fractions. It just makes it easier. And you can kind of see that if I add 4 and 4/6 over here, if I write these vertically, and I'm adding these together, I would get 7, and then I would add 4/6 plus 5/6, and that would give me 9/6. So now I have an improper fraction as part of a mixed number, because 9/6 is an improper fraction. And I can't have an improper fraction as part of a mixed number. So if I looked at that, if I had added it that way, I would have to now change that improper fraction to a mixed number and then add the 2 whole number parts together. You can add mixed numbers together without changing them into improper fractions, but then sometimes you have to deal with the improper fraction being part of the mixed number. So it's generally easier to just change them to improper fractions, add them together, and then change that whole improper fraction back to a mixed number, so you're not dealing with this situation. So here's your free response question. Your friend adds 2 mixed numbers and says the answer is 3 and 8/7. What does your friend need to do to correct her answer? So here's another example, and I've written out the steps for adding and subtracting mixed numbers here. And you should notice that steps 2 through 5 here are the same steps that we had for adding and subtracting fractions. So the only thing we've done is add an additional step when we're talking about mixed numbers of changing my mixed numbers to improper fractions. So let's look at this example to the left here and see if we can go through and follow the steps. So the first step is to change mixed numbers to improper fractions. Okay, so now I've done my first step. I need to look at my second step. I need to find a common denominator and then change these 2 fractions to equivalent fractions that have that common denominator. So I would look at 3 and 4 and say, well, one number that I know is a multiple of both 3 and 4 is 12, and I think that's the smallest one. So I'm going to go ahead and use 12. Okay, so now I've found a common denominator. Now I'm going to do my third step, which is to keep my denominator the same when I'm adding these. So my answer down here is going to have this same denominator of 12. Okay, so I did step 3. Now step 4 says add or subtract the numerators. I'm adding here, so I'm going to add these 2 numerators together, and I can see that if I add those together, I would get 95 So now I have 95 twelfths, and I want to simplify that. So if I wanted to change 95 twelfths back to a mixed number, I could use my calculator and do 95 divided by 12. And I can see it's very, very close to 8, but not quite 8. So I am going to write down that it is 7 whole. So, and then I need to figure out, well, how many of my twelfths got used up in that 7 wholes? So I'm going to do 7 times 12, and that equals 84. And so I can see that I've used up 84 twelfths in my whole. So if I subtract 84 away from 95, so I do 95 minus 84, that gives me 11. So I can see that I have 11 twelfths left over, and that makes sense because when I changed it to a decimal, it was 7.9 something. That was very close to 8, and 11 twelfths is very close to a whole. So I can also see that 11 twelfths is simplified. There's no way to simplify that more, so I've now done step 5. If you'd like to see another example like this, click on yes. If you feel like you understand this, click on no. Okay, so now I'm just going to go through these same steps again to add the 2 mixed numbers here. So again, I'm going to change my mixed numbers to improper fractions. So now I need to find a common denominator. So I'm looking at 2 and 8 and saying, well, what number is a common multiple of both 2 and 8? And I know that 2 divides evenly into 8, and so does 8. So I'm going to use 8 as my common denominator. And so 15 eighths is already in eighths, which is always nice when you can do that. And now I need to say to myself, well, what did I multiply 2 by to get 8? I know that 2 times 4 is 8, so I need to do the same thing to my numerator. 13 times 4, that would be 52. So I'm going to keep my denominator the same. Okay, done with step 3. And now I need to add or subtract my numerators. So I have 52 plus 15, and that is going to be 67. And now I just need to simplify. So I'm again going to ask myself, how many times does 8 go into 67? I happen to know that 8 times 8 is 64, so I know that 8 goes into 67 8 times. Or you could use a calculator. So I've now taken away 64 eighths from my 67 eighths, and I'm left with 3 eighths left over. And 3 eighths is in lowest terms or simplified, so I'm done, and 8 3 eighths is my answer. As an example of subtracting, if I bought 6 1/9 yards of ribbon and used 2 2/3 yards to make a pillow for FCS, how many yards would I have left over? Well, I'm going to take 6 1/9 and subtract off what I already used to figure out how much I have left over. So I would write 6 1/9, and I'd be subtracting 2 2/3. Now, when you subtract, it is really important to, again, follow my steps and change my mixed numbers to improper fractions. If I don't do that, then I end up in a situation where I might have to borrow, and borrowing is complicated when you're dealing with mixed numbers. It's not impossible, and it's certainly something that you can learn how to do if that's something you would like to do, but I'm going to just follow the steps because I can do this every time and I don't have to worry about borrowing. So just next to this, I'm going to again change these mixed numbers to improper fractions. I've done my first step, change to improper fractions, and now I need to find a common denominator. And again, I have a nice situation where one of my denominators will work as a common denominator. 3 divides evenly into 9, so I can leave 55 ninths as ninths, and then I am going to change 8 thirds so that it has a 9 in the denominator. So I'm going to multiply 3 times 3 to get 9, which means I also need to multiply 8 times 3. And 8 times 3 is 24. We are subtracting here. So I now need to subtract my numerators instead of adding. 55 minus 24 is going to give me 31. And I keep my denominator the same, so 31 ninths. and now I'm at my final step where I have to simplify. And once again, I'm lucky I don't need to simplify the 4/9. That's already simplified. So 3 4/9 yards of ribbon is how much I would have left over after I made this pillow. And here's a multiple choice question. Why do you need to change mixed numbers to improper fractions before subtracting? So go ahead and pause the video and answer this question. And here I have one more example. So pause the video now and find your own answer, and then I will show you what I got when you unpause it. My final answer was 1 1/2. Thanks a lot. Have a great day.